When you are through writing, let me know.
Yes, sir.
Now, okay, now you're
Okay, done, sir.
Okay. So let's go to cosine rule now. Cosine rule. So I will still give diagram to that effect. So triangle A, B, C. Then drop a perpendicular from C. So the point where the perpendicular hits line AB, let's call it D. So the perpendicular CD, let's call it H. Then, of course, BC is going to be A, AC is going to be B, and AB, the whole of AB is going to be C. So the whole of this is C. Now, let's now call AD. Let's call it X. So if AD is X, that means DB or BD will be C minus X. You know, C is longer. So C minus X. So you have that. So I want you to draw the diagram quickly before I start the process. So when you're done with the diagram, let me know.
Okay.
It should be true with the diagram.
Almost done, sir.
So I want to shade this part with red. For reference sake. Then I will shade the other part with blue. Now, can I continue?
Yeah, you can.
Okay.
Just
Now, I want to consider the right angle triangle. Right angle triangle ACD. ACD, that's the red part. Now, because it's a right angle triangle, so I can use Pythagoras theorem. Since this is a perpendicular here, so that means we have two right angle triangle embedded in that triangle ABCD. ABC. So the part ACD is a right angle triangle. So I can use Pythagoras theorem. So by Pythagoras, the square of B, which is the hypotenuse in that sense, equals sum of squares of the opposite and adjacent side. So square B equals square S plus square H. Call that equation 1. Similarly, consider the right angle triangle BCD. So if you consider that, that's the blue shaded part. You can also use Pythagoras with the hypotenuse in this sense to be the side A, which is side BC. So square A equals square C minus X plus square H. Call that equation 2. So write this so that I can scroll up. So when I don't write in, let me know.
yes, sir. Okay, done, sir.
Okay. So now we can say that equation 1 minus equation 2. That's the logic here. Equation 1 minus equation 2. So if I say equation 1 minus equation 2, that means the right-hand side, or the left-hand side rather, will be b squared minus a squared equals the right-hand side, which will be c minus x squared. Sorry. Will be s squared minus c minus x squared. Do you agree with that? Do you agree with that?
Yes, sir.
What has happened to h? H squared.
Wait. What? Repeat.
H squared will cancel out. Is that clear?
Oh, okay, yes, sir.
Don't forget I said equation 1 minus equation 2. So plus h squared plus a squared will cancel one another. So reason why it's not appearing here now. So take note of that. Now, I will now expand the bracket, the term in bracket. So square b minus square a equals square x minus, I will still retain brackets in expanding this c minus x. Now, why? Why am I retaining the bracket? Because of the minus here. Because the minus here is to affect all the entity after expansion. That's why you still have to retain your bracket. If you don't do that, there will be a mix-up and you will not be able to achieve our goal. So expanding c minus s will give us c squared minus 2cx plus s squared. I believe that is straightforward. So b squared minus a squared equals s squared. Then you can now open the bracket. That'll be minus c squared plus 2cx minus s squared. So with this now, s squared will cancel out. We will now be left with b squared minus a squared equals 2cx minus c squared. So we can make a squared the subject by rearranging. So if you rearrange, take a to the right-hand side and the terms in the right-hand side, take them to the left. So you have a squared equals b squared plus c squared minus 2cx. Do you agree with that?
Yes, sir.
Okay, let's call this equation 3. Now, we need to get rid of this x. We need to get rid of that x. So to get rid of that x, we'll now go back to triangle ACD. We will now use trig ratio. Don't forget triangle ACD is a right angle triangle. Is that clear? It's a right angle triangle. So if I now use trig ratio, that is SOHCAHTOA, I want to get rid of this x in equation 3. So using trig ratio, for triangle ACD, I will have cos A. So that means this side is the opposite now. Since I'm considering angle A, opposite over adjacent. Cos A equals opposite over adjacent. So in this context, this is adjacent. And that means that will be H no, triangle ACD. Sorry, adjacent over hypotenuse. That's cap. Adjacent over hypotenuse. This is hypotenuse. Since we want to get rid of x, so x over b. X over b. So make x the subject. So that implies that x equals b cos A. Equation 4. So you can now substitute 4 into 3. In other words, replace x in equation 3 with b cos A. So that will give us square A equals square B plus square C minus 2C times x, which is now b cos A. So A squared equals b squared plus c squared minus 2, if you open up that bracket, 2bc cos A. So this is cosine rule formula. This is cosine rule formula. Any question?
Yes, sir.
Okay. Please write. When you are done, let me know.
All right.
When you are through, let me know. Hello, are you there?
Yes, sir. Yeah.
Okay.
Okay, that's
Okay. Now, I've just used one side to prove the cosine rule. You can draw perpendicular in any other side, the remaining two sides, and do the same proof. But there's no need for that. So let me just say, similarly, I can have square B equals square A plus square C minus 2AC cos B. And square C equals square A plus square B minus 2AB cos C. So what did you notice in the three formulae? You will see that the side that we are looking for is the angle that faces that side that we have as cos of that. Square B cos B, square C cos C. So this suggests that if you know all the three sides, you can use cosine rule to determine the angles, one after the other. Or, on the contrary, you know two sides and the angle between the two known sides. The angle between the two known sides. I want to give this as illustration. A, B, and C. If I know side B and C, and I know the angle between them, I know this angle here. So I can use cosine rule to determine side A. Because the known angle, the angle between side B and side C that are known, is facing side A. So I can use cosine rule to determine side A. Is that clear? If I know side A and side B, and I know the angle between A and B, then I can use cosine rule to determine side C. So in that context, I will use this. Is that clear?
yes, sir.
So take note of that. So I'm going to give you an example to that effect now. So write these two, and possibly if you want to add the diagram, no problem. So when you're done writing that, let me know. Then we'll now consider examples. You should be done with that.
Yes, sir.
So let's see examples. Example 1 says from the triangle below, find the values of x and y. From the triangle below, find the values of x and y. So here is the diagram. This side is 7.5 centimeter. This side is y centimeter. This angle is given to be 57 degrees. And this angle is given to be 39 degrees. So draw the diagram quickly. So write the question, draw the diagram. When you are through, let me know. Is that clear?
Yes, sir.
Should be true writing.
Was it, sir?
I said it should be true writing.
Yeah, I'm answering. Yes, sir.
You are done writing.
You have no writing. Yes.
Okay. So how are you going to tackle this? Which of the rules do you think we handle this question?
I think it should be the sign rule.
The sign rule.
Yes,
Yes,
sir.
you are correct. The sign rule. The sign rule. So let's now tag the side so that our work will be very easier to handle. So let's call this, that's part of my solution. So let's call this A, B, and C. So sign rule says, so if this angle here is A, so that means this side will be side A, this side will be side B, and this will be side C. So by sign rule, A over sine A equals B over sine B equals C over sine C. So let's substitute appropriately. Our side A is y. So that's y over sine 57, that's angle A, equals side B. Our side B is 7.5 over angle B, which we don't know, equals side C. We don't know that either, over angle C, which is 39. Oh, this place is X. I didn't put it. So this is X. So that means our angle B is X. Let me change it to X. So this is X. Now the question says we should find X and Y. And remember I told you, you can combine any two. You can combine any two. So how do we do that now? How do we combine?
We combine by time minusing. Is it minus?
How do we combine any two?
Divide.
No. As it is now, it will be difficult to combine any two because you can see that
Oh
we
yeah,
have,
because each we don't have we don't have three pieces of information.
I didn't get that.
We do not have three pieces of information in for two.
Yes, we have three unknown. But you can make life easy by determining angle X. Now, what's the sum of angle in a triangle? 180.
One
Is that not it? So I can say that X plus 57 plus 39 equals 180 degree. Sum of angles in a triangle. So that will help us to determine the value of X. So X will now be 180 minus 57 minus 39. Is that clear?
Yes, sir.
Yeah, press your calculator for that. 180 minus 57 minus 39. That should be 84. So S is 84 degree. Is that clear? So I can now combine the first two. Y over sine 57 equals 7.5 over sine X, and S is 84. So with this now, I can determine the value of Y. So if you cross multiply, you have Y sine 84 equals 7.5 sine 57. Make Y the subject, 7.5 sine 57 divide by sine 84. So press your calculator and tell me the outcome.
Wait.
Press your calculator and tell me the outcome.
Uh, 6.3.
6.3. Is your
Yes.
calculator in degree?
Yes, sir.
Okay, let me verify. Okay. Since the question did not specify the degree of our approximation, so 6.3 centimeter will be correct. So that's why. So we have answered the question. So write that. And when you are through, let me know. Excuse me.
Okay, done, sir.
Okay. So let's see second example. Number 2 says, calculate the missing side from the triangle ABC below. Calculate the missing side from the triangle ABC below. So here is the triangle. A, B, C. So this side is 8.4 centimeter. This is 6.5 centimeter. And this angle here is given to be 20 degrees. Write that quickly. Draw the diagram. Then we'll now see the solution.
It done, sir.
Okay. So now, which of the rules do you think will be able to handle this? Are they?
Yes, sir.
So which of the rules do you think will handle this problem?
Cosine rule.
Cosine rule. How do you know it's cosine rule?
Because you got two sides and one angle.
Two side and the included angle. Very good. So that means we are looking for side C. So this is side B and this is side A. So that means my cosine rule will now go this way. Since I'm looking for side C, so it will be C squared equals A squared plus B squared minus 2AB cos C. So this will be side A, which is 6.5 squared, plus side B, which is 8.4 squared, minus 2 times 6.5 times 8.4 cos 20 degree. So you now take your calculator. So 6.5 squared 6.5 squared, that's 42 42.25. 42.25 plus 8.4 squared, 70.56 minus 2 times 6.5 times 8.4. 109.2 times cos 20. Now at this point, your calculator must be in degree, and that's 0.9397. 9397. Now, let me sound a note of warning. Do not truncate the digit. For instance, now, 42.25. Don't quickly write it as 42.3. Don't approximate at this level. If you have it more than this digit, if you are to truncate, make sure you truncate and leave it in 4 decimal places, like I've left it for this angle now. 0.9397. Don't just write 0.93 or 0.94. No. If you do that, it will affect your final answer, and they are going to have what we call cumulative error of approximation. Is that clear? Hello, Ade, are you there?
Yes, sir. Yes, sir.
Hope what I've explained is clear to you now.
Yes, sir.
Okay. So 42.25 plus 70.56. That gives 112 rather, 0.81 minus 109.2 times 0.9397. That gives 102.61524. You now subtract 112.81 minus 102.61524. That gives 10.19476. So that's C squared, that is up to that. So what is now C? C will now be square root of that. 10.19476. So that gives 3.1929. Therefore, C equals 3.2 centimeter. 3.2 centimeter. Is that clear?
Yes, sir.
Any question?
No, sir.
Okay. So copy that. When you are done, let me know.
Okay, done, sir.
Okay. So I'm going to give you an assignment now. I'm going to give you 3 questions. So the question says in triangle ABC, it is given that A equals 8 centimeter, A equals 30 degree, and B equals 72 degree. Find the value of B. Take note of my lettering. Where I've used small letter, use small letter. Where I've used capital, use capital. Is that clear?
Yes, sir.
Okay, that's question 1. Question 2. Question 2 says from the triangle above, find the value of X. Question 3 says the distance from the T to the flag F on a particular O. On a golf course is 494 yards. Are you done with question 2? I want to stroll up.
Yes, sir. I've done question 2.
Okay.
Oh, the distance from the what? From the
From
phone number
the
thing is
T. The distance from the T-double-E. These are terminologies used by golfers. So the distance from the T to the flag F on a particular O on a golf course is 494 yards. A golfer's tee shot. Golfer's tee shot travels 220 yards. And lands at the point X. And lands at point X where angle STF equals 22 degrees. So the question now say calculate how far the ball is from the flag. Calculate how far the ball is from the flag. Let me go through everything. The distance from the T to the flag F on a particular O on a golf course is 494 yards. A golfer's tee shot travels 220 yards and lands at the point S, where angle STF equals 22 degrees. Calculate how far the ball is from the flag. So that's the question.
Yes, sir.
Where you're not writing, let me know.
Okay. Okay, then, sir. Don't
Okay.
write in.
So that's the question to be submitted tomorrow latest. Is that agreeable? Are they?
Yes, sir.
Is that agreeable to be submitted tomorrow latest?
Yes, sir. I'll try to read before the
You
tomorrow,
have
please.
to. You're on break. It's just 3 questions.
Yes, sir.
All right. So I'll be expecting your response to that.
Yeah.
Bye.
Bye.